Hi everyone, we did visual grounding this semester. Our members are Wenxuan, Litao, Jiajun, and Yiming. Visual grounding aims to locate the most relevant object or region in an image based on an NLP query. For example, given the phrase panda looking at camera, after grounding, we want to locate the cute panda that is greeting us in the picture. Visual grounding is a combined computer vision and NLP task. There are one-stage and two-stage approaches to this task. Two-stage approach generates potential regional candidates from the image and then choose the best matching candidates based on the text. While one-stage approach tries to localize object directly based on text. In our project, we analyzed the transformer-based one-stage models and experimented with a few modified architectures.
In this project, we use RefCoco as our testing and training data. It's widely used in visual grounding researches. It's lightweighted and really easily accessible. The data is split into people versus people tests and object versus object test. And below, you can see a typical RefCoco data. It consists of an image and referring expressions on the right. According to the published result, TransVG has the best performance with RefCoco, and that's one of the reasons why we choose this data set as our training data.
The model that we use is the one in the TransVG paper, where it comprises 4 subcomponents: the visual model, which is in the green box, the linguistic model, which is blue box, the visual language fusion model, which is the orange box, and a prediction head, which is a purple box. The prediction head is used to compute the 4-dimensional box coordinates. In each transformer box, multiple transformer encoder layers are stacked to form a transformer for different uses. The approach that we use in our project is to replace the backbone in the visual branch from resonant 50 to wide resonant 50. First of all, let me introduce the basic block in the wide resonant 50. In the block shown on the left, the number of channels in each convolution layer is 64 times 2 equal to 128, which doubles the number of channels proposed in the original paper for resonant 50. One of the reasons that we use this network is wider network tend to be able to capture more fine-grained features in the input images. However, due to the fact that the increased number of channels resulted in the increased number of parameters, the model may overfit. Therefore, a dropout layer is applied before the residual connection. Another reason that we choose to use wide resonant 50 is that in the ImageNet dataset, the one crop top volume error rate is 76.468%, which is higher than the result got from the resonant 50. And the table on the right shows the difference between the resonant 50 and wide resonant 50. Therefore, we consider that the use of wide resonant is probably a good substitution for the resonant. And this is the modified flowchart where the original resonant is replaced with a wide resonant 50.
Now let's talk about the experiments and results we've got. We use top 1 accuracy as our evaluation metrics. We trained both FLOA and TransVG on the RefCoco dataset with up to 4 NVIDIA Titan XP GPUs on our cluster. We trained FLOA on 1 GPU around 40 hours to get around 72% of accuracy as reported in the paper. And we trained almost doubled up to 70 hours on 4 GPUs on ResNet 50 for TransVG, up to around 80% of validation accuracy as reported on the paper. And for our own wide ResNet 50 model invariant, we train even more, up to 73 hours on 4 GPUs, but only get around 74% of accuracy. We did not expect our wide ResNet to perform worse than the original ResNet 50. It reaches best performance in a very little number of epochs, but as the training goes further, the validation accuracy drops. We think this is probably because that we have no pre-trained weights to use. What we've learned that visual grounding is a challenging topic. There are a lot of nuances to tune, and initialization is very crucial to get optimal performance, say the pre-trained weights. And sometimes it's better to use smaller models in terms of training time. Thank you for listening.